So in this video, we are going to discuss another important concept from data structures and algorithm, that is searching on unsorted linked list. Let us consider this is a linked list contain four number of nodes, and each node contain different data A, C, B, E, and these are the addresses of the nodes, and the link part of the first node that gives the address of the second node. The link part of the second node gives the address of the third node. Similarly, the link part of the third node gives the address of the fourth node. So this is how actually the nodes are get connected. It is a null pointer. It represents no more nodes available in the list. So in the given linked list, we want to search for a particular element, whether this element is present in this linked list or not. Let us consider we want to search for item, that is B. Our item value is equal to, that is B. So every time we check the information part of the node, because the item, that is the data, we want to check that whether this data is available in the linked list. First we are checking the first node, so check the information part. It is not B, so we move on to the next node. So in order to moving to the next node, we have to use this link part of the first node. So only that gives the value of the second node. Okay, so for that we are assigning a pointer, that is PTR. So only using initially we are taking this PTR as equal to this start value. The starting pointer, it is nothing but 5. So that is the first node. So then we are moving the pointer, that is PTR, to the next node by copying the link part of PTR on PTR itself. Okay, so it moves here. Check the value of the information part of the second node with the given item. Again, if it is not, we are storing the link part of this PTR in PTR. So the link part of PTR is 6. Now automatically the PTR moves to the next node. Here we are checking that the information part of this third node, whether it is equal to the given value. Both are equal. So then, that being the case, we can stop the process and we'll note down the location. So print the location and you can stop. If let us consider if it is not equal, so that being the case, we have to again move the pointer to the next location, and you have to check that. Let us consider the required item, it is a D, it is not available. So automatically we have to store the null value in the location. So this is the algorithm that is given here. Let us see the various steps. So in the search content, these are the important the variables we are going to use in this algorithm: info, link, start, item, and LOC. So list is a linked list in memory. This algorithm finds the location, that is LOC, of the node where the item first appears in the list. If the item is not available in the list, we have to print, that is set the location to null. So initially we are taking this pointer, as I said, PTR is equal to start. So let us consider the step 1. It is step 1. So here the PTR value, it is equal to the start value. Starting address is nothing but 5. Let us consider 5. So repeat while PTR is not equal to null. We have to repeat the procedure. We have to perform this operation, all the operation that is below this. So check that the PTR value, it is not null. So now we have to proceed. If item value, so let us consider if the item is B. If item, that is the information part of the PTR, check the both are if equal, that is item is B and the information part of the PTR, it is nothing but A. So check that A is equal to B. it is not equal. So automatically we have to, that is go to the else part, that is store the link part of PTR in PTR. So what is the link part of PTR? Link part of PTR, it is 7. So we are storing the value, that is 7 here. So go to, that is step 2. So now the PTR value, it is 7. It is not null. So then we have checked the information part of the PTR. So the information part, it is moved here. So the information part of the PTR, it is C. Check that B is equal to C. It is not equal. So again, that is the link part of PTR stored in PTR. So now the PTR value, it is a PTR value, it is stored, that is 6. Okay. Step number 3. Now PTR is equal to 6. In location 6, now PTR is here. Check the value, that is the required value, that is B is equal to B. If B both are equal, so then that being the case, set the location, that is location is equal to PTR. So what is the value of this location? It is 6. So location is equal to 6 written. We can stop the process. So here we are able to, that is identify where the required element is available in the list. We can stop the process. Otherwise, let us consider our required item is not B, instead it is D. So that being the case, the required value, it is D. So that being the case, we proceed the process. That is the link part of PTR stored in PTR. So now the PTR value is equal to, that is 9. Okay. Step number 4. Step 4. Now PTR is equal to 9. The information part of the PTR, check that that is D is equal to, that is E. Required value is D and available value is E. So again, both are not that is equal, not equal. Store the value of the link part of PTR in PTR. So PTR now it is equal to, that is null. So link part of PTR is null. So again now we go to, what is that the step here, that is PTR is equal to, that is step 5. PTR is equal to, that is null. So that being the case, what you have to do? The condition is not satisfied. Simply just come to the step number 3. Set LOC is equal to null. Now LOC is equal to null. Stop the process. Okay. So if the required value is available in the list, it will just find out its location. If the required value is not available in the given list, simply it will give the result, that is null. Okay, so that means the search is unsuccessful. The required value is not available in the list. So this is a simple algorithm. I hope you understood the concept. Thank you. Keep watching.